power of a power. That means that we're taking an expression that's written exponentially and we're raising it with another exponent. When we have a power of a power, then we are going to multiply the exponents together. Now here's how I want you to remember the difference. In this case, see how the m and n are very close together, just like they would be if we were writing them, you know, the way that we multiply variables. So let that be like a signal to yourself that when they're close together like that with just the parentheses separating them, then that means that you have to multiply them. So something like that, right? All right, so let's look at it. We're going to start off easy. X to the third to the fourth. So we're taking a power of a power here, so we have to multiply our exponents, and we get x to the 12th. In the next one, again, we're doing a power of a power, so we have to multiply. So over here off to the side, I'm going to have 1/3 times 8. Now, the way that I always like to write it if I'm doing a fraction times an integer is I like to put it over 1. So I would rewrite this as 1/3 times 8 over 1. And then with multiplication, we just do top times top and bottom times bottom. So we get x to the 8/3 here, right? X to the 8/3. Now, that's a mixed number. So we do have other options. If we were to write this in radical form, because sometimes that's what's asked. So if we were to write this in radical form, we could look at it as the 3 would come out, right? That would be our index number. And then we would have x to the 8th. Now, anytime, I want you to think about this for a moment. Think about if I take the square root of a number that's squared. The square root of a number that's squared. So if I take the square root of 16, the square root of 16 is 4. Now the reason that that works and the way that you can look out for it is the index number matches the exponent number. When the index number matches the exponent number, this is the kind of situation I've got. I'm squaring something, but then also square rooting it. So it's inverses, right? One operation undoes the other. So likewise, if I have a cube root of a number that's cubed, that would just be my base. Because if I'm cubing something and then I'm cube rooting it, I'm back to where I started. So when we have something like this, where it's an improper fraction and the number on the top is greater than the number on the bottom, we can split this up into some x cubes, right? So if I want to try to match the index number, I could have an x cubed. I could have another x cubed. So far I've got, if I add my exponents, I've got 6. And then I could have an x squared. That would make 8. So what I'm trying to do is I'm trying to make 8, but I'm trying to start with the x cubes because every time I have a cube root of x, let me put my cube root in there, my cube root of x cubed, that means I can take it out. So now I'm going to do it one at a time. The cube root of this first x cubed is just going to be x. The cube root of this second x cubed is also just going to be x. And for the last one, I don't have enough to take it out, so that's going to stay x squared. Actually, x to the 2/3, sorry. Right? So now I've got x times x to the 2/3. If I wanted to write this in radical form, x times x is x squared, and then x to the 2/3, I could put it back in radical form. It just depends on how you're supposed to write the answer. And it will always tell you whether you're supposed to write it in radical form or exponential form. Now, just to be clear, what we started with up here is fine. If I asked you for exponential form, that's fine. This is also fine. These are all correct answers. But if you find that you're in a multiple choice situation and you're looking for an answer and it's not one of these, then that means that you may need to go a little bit further with it. All right, so let's look at that same thing again, because we're going to have the same situation over here. Because when we multiply 7 and 1/2, we're going to get x to the 7/2. So again, we've got an exponent that is an improper fraction. So when I rewrite it, I'm going to kick the 2 out, so I'm going to have the square root of x to the 7th. Now remember, every time I have an x squared in there, I take the square root, and so that means I get just x. So I can rewrite this as, let's start. I've got an x squared. I can do another x squared. I can do another x squared. That gives me 6 so far, and then an x. So each time I'm taking the square root of an x squared, that's just equal to x. So this one would equal x, square root of x squared, square root of x squared, and then this one I can't do anything with. It would just stay square root of x. So I would be left with x cubed times the square root of x. And again, this answer is correct. This answer is correct. And sometimes that's as far as you'll have to go. But if you're taking a test and you don't see either of those answers as an answer choice, then you may have to take it farther, which means that you're looking to match the index number. Because when the index number matches the exponent, that means that you just get the base as your answer, just like we saw over here. So square root of x squared, square root of x squared is x. Square root of this x squared is x. Square root of this x squared is also x. And then I've got square root of x to the first, so that just stays as the square root of x. Then I can multiply them and get x to the 3rd power times the square root of x.